right triangles. And this time, instead of the tangent ratio, we're going to be looking at the sine ratio. The sine ratio is the side opposite divided by the hypotenuse in relationship to our reference angle, the side opposite divided by the hypotenuse. So in number 2, if we're looking at angle B as my reference angle, the side that is opposite is the side that's 7, and the hypotenuse is 14. So the sine of angle B is equal to the opposite divided by the hypotenuse, which is 1/2. Number 4, my reference angle is angle D. So the sine of angle D is the side opposite divided by the hypotenuse, and 6 does go into 54 9 times. So we're going to find the sine of 45 degrees the same way as we found the tangent of 45 degrees. But this time, we're going to select the sine key. And let's see, then we'll need to round it to the nearest hundredth. So we're going to round that to 0.71. Again, we can write a ratio as a decimal. So we're going to find the lengths of sides using a sine function. And we're going to begin by writing an equation that can help me to find x. So my reference angle is 60 degrees. So the tangent of, the sine of 60 degrees is equal to the side opposite divided by the hypotenuse. Now I chose to use the sine function because they did tell me these two sides, and unfortunately I can't use tangent because tangent only works when I know the opposite side and the adjacent side. So because I knew the opposite side and the hypotenuse, this time I'm going to use sine. But I solve these the same way as I solved the previous equations. I'm going to cross multiply. Get about 5.2. And I go back and look at my triangle, and in terms of the entire triangle, the side that's x does appear to be reasonable with a length of 5.2. So here's my reference angle. Here's my opposite side. Here's the hypotenuse. So we can say the sine of 5 degrees is equal to the opposite side divided by the hypotenuse. I'm going to cross multiply. And then to solve for x, I need to divide by the sine of 5 degrees. Now, number 12, we need to find the measure of angle x. So once again, we need to use our inverse function on our calculator so that we can find the measure of an angle. In relationship to my reference angle, this side is the opposite side. This side is the hypotenuse. It's the longest side. So I need to use the inverse of sine. And the side that's opposite, angle x is 30. Side that is the hypotenuse is 42. So once again, I begin with second function, sine. 30 divided by 42. And we get a measure of about 45.6 degrees. All right, in this diagram, we have a diagonal support inside this arch. And the question is, how long is this diagonal support? So we'll call this x. Here's my reference angle. This side is opposite. This side is the hypotenuse. So again, we're going to use the sine function. And we get x is about 20.9. And that's in terms of feet. So we have a hot air balloon that's 125 feet in the air. And it was blown to the side, and the question is, how long is the piece of rope that connects the balloon to the ground? So we're looking for the side, the hypotenuse, and so we'll call that side x. So my reference angle is 9 degrees. The side is opposite my reference angle, and this side is the hypotenuse. So we have some review questions that take us back to the beginning of, I believe, chapter 2, where we learned all the angles in a triangle have a sum of 180 degrees. The three angles in a triangle equal 180. So I need to write an equation to help me to find x. So the first angle in my triangle is x degrees. My second angle is 3x degrees, and the third angle is 4x. And altogether, those three angles add up to 180 degrees. So we have 1x plus 3x is 4x, plus another 4x gives me 8x equals 180 degrees. So x is 22.5. And again, we're going back to review the relationship of the sides in a 30, 60, 90 right triangle. And in this particular triangle, we know the long leg. And here's the short leg. And here's the hypotenuse. So if I want to go from the long leg to the short leg, I need to take 8 and divide it by radical 3. And then from the short leg to the hypotenuse, I'm going to double the short leg, and that gives me 16 divided by radical 3. So we're going to review another proof, and this one has some interesting information in the given. So let's just review what the symbol means. The symbol means parallel to. It does not mean congruent. It means that those two segments are parallel. So I'm going to put a little mark here. SK is parallel to NR. And then we have another pair of parallel sides. These two sides are also parallel. So here's what we have. When we have two parallel lines cut by a transversal, let's highlight the transversal. Let's try that again. Okay, so we have two pair of parallel lines cut by a transversal, and so what we have formed is angle 1 and angle 3 are alternate interior angles. And what we know about alternate interior angles is that they are congruent if indeed we have parallel lines. So in this diagram we have angle 1 is congruent to angle 3. So for one pair of angles, we're off to a start. In addition, angle 2 is congruent to angle 4 because they are also alternate interior angles. And then finally, we need one more thing to say that the triangles are congruent. And in this diagram, I noticed that both triangles share a common side, and that would be segment SR. So we're going to say that they share a side in common for one pair of sides. So if we are trying to prove that these parts are congruent, the first thing we need to do is to prove that the two triangles are congruent. So let's start with the given. So because we have the parallel sides, we can now say that angle 1 is congruent to angle 3. And in the same step, I'm going to say that angle 2 is congruent to angle 4. And we're simply going to write alternate interior angles. So again, what we know about alternate interior angles is that they are congruent if we have parallel lines. So that takes care of both of those. In this diagram, segment SR is actually congruent to segment RS. So there's our pair of sides that are congruent. So we can now conclude that triangle SKR is congruent to triangle RNS. And that would be by angle side angle. So now that we have two congruent triangles, we can now say that SK, which corresponds to segment NR, and I'm going to actually say RN, and segment SN, which corresponds to segment RK, are congruent to each other. Now all those are corresponding parts, and they do belong to congruent triangles, therefore they are also congruent.